Hi, now we are going to discuss about number theory concepts. So, number theory. In number theory, there are so many applications regarding CSE field. So, in particularly, we are going to discuss about linear Diophantine equation. So, linear Diophantine equation. What is linear Diophantine equation? As we know, in the lower class we are solving the two simultaneous equation, right? So number of unknowns, suppose if it is number of unknown is 2, then the equation will be 2. If the number of unknown is 3, then number of equation will be 3. Then you can easily able to solve the, and you can find the value of x, y, z. Suppose if we have a single equation, for example, see, ax plus by equal to c. It is a single equation, but it consisting of two unknowns. So that type of equation is called Diophantine equations. So in single equation, we can found more number of unknowns and we can easily able to solve. So that type of equation is called Diophantine equation. What is linear is nothing but power is 1. So that is called linear Diophantine equations. So in linear Diophantine equation, there is one specific note for that. So note. So this is the important note you have to follow for linear Diophantine equation. So what is the note is ax plus by equal to c is solvable. So first we have to check whether that equation is solvable or not. So ax plus by equal to c is solvable if d divides c. So this is the main condition you have to follow. So ax plus by equal to c is a linear Diophantine equation, is said to be a solvable if d divides c. If d divides c, then you can say it is solvable. Then the solution exists. Then the solution is x equal to x naught plus y by d into t, where t belongs to z. Next, y equal to y naught minus a by b by d into t, a by d into t, where t belongs to z. So this is the solution if it is solvable. Once again I repeat the concept. So linear Diophantine equation general form is ax plus by equal to c. This is the general form of the linear Diophantine equation, and you can you have to check first whether it is solvable or not. How to check whether it is solvable is d divides c. If this condition is satisfied, you can say this equation is solvable, then the solution exists. What is the solution of this linear Diophantine equation is x equal to x naught plus b by d into t, where t belongs to z. Z is a integer, and y equal to y naught minus a by d into t, t belongs to z. And we have to know what is a, b, nothing but the coefficient of x and y. Okay, and t belongs to z, it belongs to any integer. And what is this x naught y naught is a particular solution. So depends upon the problem, x naught y naught will vary. And what about d is nothing but GCD of a comma b. So this parenthesis representation of the GCD. So this parenthesis is representation of the GCD is nothing but d. So what is d is you have to find out the GCD of a comma b. So this is the way you have to approach for the problem. So once again repeat the concept. The linear Diophantine equation general form is ax plus by equal to c. When when the solution exists is whether it is solvable, then the solution exists. How to check it is solvable is d divides c. Suppose the condition is satisfied, then the solution of the linear Diophantine equation is x equal to x naught plus b by d into t, where t belongs to z, y equal to y naught minus a by d into t, t belongs to z. Then we move on to the problem. So first problem is solve 12x plus 18y equal to 30. You have to solve the equation 12x plus 18y plus equal to 30 if it's solvable. So first you have to check whether the equation is solvable or not, then the solution exists. Now before entering into the solution, whether it is a linear Diophantine equation, yes. So the power is 1 and it consisting of one equation with more two unknowns. So this equation is linear Diophantine equation. So you have to solve. Then what is the general equation of the linear Diophantine equation is ax plus by equal to c. Just compare the equation with the question. You can find out here a equal to the corresponding x coefficient is a. What is your x coefficient? 12. And the corresponding y coefficient is b is 18 and the constant is 30. So after finding ABC, we have to find out the value D. What is D? D is nothing but the GCD of A comma B. So A is 12, B is 18. We have to find out the GCD for these two numbers. How? Already we discussed in the previous video. So highest number inside and lowest number outside, just divide. 112 is 12, remainder is 6, just put inside this. So 12, so 2 6 are 12, remainder is 0. So how to find the GCD is when the value becomes 0 using 6. So that is the GCD of this both value. When you get the remainder value is 0, that divisor is called the GCD. So 6 is the GCD of 12 comma 18. Okay. Now we have to check whether this equation is solvable or not. What is the condition to check it is a solvable? D divides C. So just replace what is D is 6 divides what is your C is 30. We have to check whether it is divides or not. Already we discussed in the previous video what is the divide concept. So nothing but A divides B is B can be second term, B can be expressed as first term into some other integer C, that if we express in terms of B equal to AC, then you can say A divides B. This is the divisibility concept. So how to check it is a divisibility concept is, so second number 30 can be expressed as first term into some other integer. It should not be a fraction, it should be an integer. So any plus or minus as they wish. So what is the value will be 5. So you can express this 30 as 6 into 5. So if it is expressed in the term of B equal to AC, then you can say 6 divides 30. So obviously you can say 6 divides 30. If the condition is satisfied, you can say it is solvable. Therefore, linear Diophantine equation, that is 12x plus 18y equal to 30 is solvable. Once it is solvable, you can able to find the value solution. So how the solution exists? So simple logic. What is the formula for solution? Is x equal to x naught plus b by d into t. Then y equal to y naught minus a by d into t, where t belongs to z. This is the formula for the solution of LDE. Just replace. Before entering into that, we know the value of b, a, d, and we have to find out what is x naught and what is y naught. How to find x naught y naught is a trial solution. So this x naught y naught, we can say it is a trial solution or particular solution, is nothing but just replace x and y value, any value that would occurs the right hand side. So it is easy, right? So if you substitute x value as 1, you as your wish, you can choose any value. Suppose if you choose x value as 1 and y value as 1, what happens? 12 plus 18 automatically become 30. So you can take x naught y naught as a particular solution as 1 comma 1. Not only 1 comma 1, there are so many solution, particular solution can exist, but this is also one of the particular solution. So just find out here x naught as 1. This is the trial solution. So x naught as 1, y naught as 1. If you substitute this x naught, y naught in this equation, suppose x naught as 1, y naught as 1, now what is the value will be? 12 plus 18 equal to 30. You will get the right hand side value. So this is one of the trial solution. So just replace in the formula x equal to, what is your x naught value is 1 plus b. What is the b? The corresponding y coefficient divided by, what is your D? The GCD of A comma B as 6 into T. This implies 1 plus, what is 18 by 6 is 3. So this is the value of X. So once again repeat, just replace x naught value as 1. This is a trial solution, plus B, the corresponding y coefficient as a B, 18 by D. D is nothing but GCD of A comma B is 6 into T. Just simplify, you will get 1 plus 3T. And similarly, what about y value is? Y naught value is also 1, because we are taking the trial solution y naught as a 1 minus A. A is nothing but the corresponding x coefficient 12 by GCD of D is 6 into T. This is nothing but 1 minus 2T. So the final solution of this linear Diophantine equation is x equal to 1 plus 3T, y equal to 1 minus 2T, where T belongs to Z. So this is the final solution of this linear Diophantine equation. How to check whether this is equation is right or not? So just replace T in terms, any integer value you can replace. Just replace T value as 0. Simple value, just take as T value as 0. What happens to X is 1. If you take T value as 0, what happens to Y is 1. If you take 1 comma 1 and then substitute in the general original equation, automatically you get the value of right hand side. So that is the right one. And you can take any other than 1. Suppose if you choose T value as 0. Suppose if you take T value as 1. If you take T value as 0, it become 1 and 1. The right hand side exists. Okay. If suppose if you choose a T value as 1, what happens to X and what happens to Y? So T value is 1, 3 plus 1 is 4. Next, similarly, T value is 1. So 1 minus 2. 1 minus 2 is minus 1. So this is also one of the solution of this linear Diophantine equation. How to check? Just substitute x and y in this equation. So 12 fours are plus 18 into minus 1. If you simplify, you will get the value as 30. So this is the simplest way of finding linear Diophantine equation solution. Shall we move on to the next one? Yes. So similarly, I am just replacing the second term. Second question, similarly, solve 12x plus 16y equal to 18. So we have to check whether it is solvable. Suppose if it is solvable, then we have to find the solution of this linear Diophantine equation. First, we have to know what is linear Diophantine equation. Linear is power is 1. Yes, obviously, then it contains one equation with more number of unknowns. Here, two number of unknowns. So single equation with two unknowns. So this belongs to linear Diophantine equation. So you have to solve this linear Diophantine equation once if it is solvable. If it is not solvable, you cannot find the solution of this linear Diophantine equation. So we can proceed the solution. So what is the general equation of the linear Diophantine equation is ax plus by equal to c. Just compare with your question. Here a is 12, B as 16, C as 18. So what is the next procedure? We have to find the D value. So D is nothing but GCD of A comma B. So what is A value is 12 and what is B value is 18. Just find out the GCD of this both numbers. How to find the GCD of this number is you have to put the highest value inside, lowest value outside. Just divide as 112 is 12, remainder is 6, just inside the quotient divisor brings to the dividend, so 12. So 2 6 are 12, remainder is 0. So you will get the value 0 when if you divide by 6. So that is this non-zero remainder is a GCD. So what is the GCD of 12 comma 18 is 6. So what is the condition to check it is solvable or not? D divides C. What is your D value is 6 divides what is your C value is 18. So this is nothing but 18. So second term can be expressed as first term into some other integer. What integer will be? So 6 3s are 18. So you can express this value as 18 as 6 into 3. So it is a divisibility concept. So according to the divisibility concept, if it is A divides B, what happens? Second term can be expressed as first term into some other integer C. So similarly, 18 can be expressed as first term, second term can be expressed as first term into some other integer. So it is solvable. Therefore, it is solvable. If it is solvable, then the solution exists for this linear Diophantine equation. So what is the solution of the linear Diophantine equation is? The solution is formula of x equal to x naught plus b by d into t and y equal to y naught minus a by d into t, where t belongs to z. So this is the formula for solution of linear Diophantine equation. Just we have to find out the trial solution. So because already we know what is a, b, d and t is belongs to z, we have to find out only x naught and y naught. What is x naught and y naught is the trial solution. So how to find the trial solution? Already we discussed in the first problem. How to find the trial solution of x naught and y naught is, just we can substitute any value of x and y in the given question. Yes, what we can substitute is, you can take any value of x and y as you wish, but if you substitute x and y in this equation, automatically right hand side should be exist. So how? So this is the simplest way to find. If you substitute 1 and 1, you cannot get the value as 18. So this is not a so there is a general way to find out the trial solution of x and y. How? So nothing but just I am expressing, just find out the GCD of this. 6 2s are 12, remainder is so 18 and value is 1 second. So D is nothing but GCD of A comma B is, so 16 12. So 16 12, 112 is 12, remainder is 4 and inside just express. So we have to find out whether it is solvable or not, then we have to find out the solution. So how to check whether it is solvable or not? What is A value as 12, B value was 16, C value was 18. So then we have to find out the D value. What is D is nothing but GCD of A comma B. So what is the A value is 12 and B value is 16. You have to find out the GCD of this 12 and 16. How to find the GCD? As per the previous problem, we have to put the highest number inside and the lowest number outside. 112 is 12 and what is the remainder will be 4 and inside 12. So 4 3s are 12, remainder is 0. What is the non-zero remainder of this? This is a 0 remainder and this is the non-zero remainder of this both number, and what is the GCD is 4. So the least non-zero remainder is your GCD of this both numbers. So 12 comma 16 as 4. So we have to check whether it is solvable or not. How? D divides C. No. Now what is D value is 4 divides C. What is your C is 18. So what is the divisibility concept is? According to the definition, A divides B is, B can be expressed as first term into some other integer. So here what is the second term? 18 can be expressed as the first term into some other integer. Substitute 1, 4, 2, 8, 3, 12. If you substitute 4, it becomes 16. If you substitute 5, it becomes 20. You have to substitute only the integer value, not a fraction value. So we cannot find out the integer. So it become a fraction. So we cannot express 18 as 4 into some other integer. So we cannot as D does not divide C. So if it is expressed as a B as AC, then you can say is a solvable. but we cannot express 18 as 4 into some other integer. So D does not divide C. If the condition is failed, you can say the solution does not exist for this linear Diophantine equation. Therefore, the solution does not exist for this particular problem because the condition is not solvable. If it is not solvable, you cannot find out the solution. So this is the contra example for this linear Diophantine equation. Next. So this is another main important problem. Same value, you have to check the linear Diophantine equation is solvable or not. So why I am choosing this problem is the way of finding x naught and y naught is differ from the first problem. So solution. Similarly, what is A is, I am just writing directly what is A as 15, B as 21, C is 39. We have to find the GCD D as GCD of A comma B as 15 comma 21. How to find the GCD? Just highest value inside, lowest value outside. 115s are 15, remainder is 6, right? Then obviously the 15 goes inside, so 6 2s are 12, remainder is 3. Then inside 6, 2 3s are 6, remainder is 0. So what is the least non-zero remainder of this is 3. So GCD of 15 comma 21 is 3. So least non-zero remainder is your GCD. So GCD is 3. So we have to check whether it is solvable or not. What is the condition to check solvable? D divides C. What is D? 3 divides, what is your C value is 39. So according to the divisibility concept, you can say second term can be expressed as 3 into some other integer. What integer you can be written? 13. So 13 3s are 39. You can express 39 as 3 into 13. So it is solvable. It is solvable. If the linear Diophantine equation is solvable, then the solution exists. What is the solution will be? Solution is x equal to x naught plus b by d into t, y equal to y naught minus a by d into t. So we already know the value of a, b, d and t belongs to z. So simply we have to find out what is x naught and y naught. It is very different from the other problem, because if you substitute 1 directly, you cannot get the value of 39. So just substitute 1, you cannot get the value as 39. So what is the general procedure to find the particular solution x naught y naught is, see, using this GCD concept, that is called Euclidean algorithm. So using of Euclidean algorithm, you can easily able to find the linear combination of the two numbers. Using that linear combination, you can easily find out what is x naught and what is y naught. How? See, you know already the division algorithm, right? So you can write this 21 as, this value can be expressed as quotient into divisor plus remainder. So 1 into 15 plus 6, quotient into divisor plus remainder. This 21 can be expressed as. Similarly, this 15, this inside value 15 can be expressed as quotient into divisor plus remainder. So 2 into 3, 2 into 6 plus 3. Similarly, this 6 can be expressed as quotient into divisor plus remainder. So we have to choose the least non-zero remainder. So this is your remainder portion. What is the least non-zero remainder is 3. So that is your GCD. Okay. So using this concept, we can express as a linear combination of the two numbers. How? See, we have to start from the least non-zero. So that is 3. How can 3 expressed as 15 minus 2 into 6? So this 3 can be expressed as 15, this 2 into 6 brings to the that side, minus 2 into 6. So 15 minus 2 into this 6. Where is 6? Here. Again, the least non-zero remainder is 6. How you can express 6 as 21, thus bring to that side 1 into 15. So this 6 can be expressed as 21 minus 1 into 15. Just multiply. So 15 minus, just multiply 2 into 21, minus into minus, plus 2 into 15. Don't multiply 2 into 15 as 30. Just keep 2 into 1 as 2 into 15. Now we have to rearrange as, see, 15, here also 15, here is nothing but 1 into 15. So group it, 1 into 15 plus 2 into 15 can be add as 3 into 15. Only add 2 plus 1 as 3 into 15 minus 2 into 21. So this 3 can be expressed as 3 into 15 minus 2 into 21. How it check whether it is a right or not? See, inside value is nothing but your GCD number. See, 21 and 15 should be appear in the inside the parenthesis. Okay, now just compare question with this expression. Just compare the question with the expression. What is lagging? See, 15. Yes, 15 is there, and near to the value of 15 is x. Okay, and 21. Yes, 21 is there. Near to the value of 21 is y value. But what is your right hand side value is 39. But here right hand side is 3. So it is, we have to adjust some value. How to get the value 39 is, we have to multiply throughout 13 on both sides. So just I am writing the expression 3 as 3 into 15 minus 2 into 21. So we have to get the value as 39. So how to find the 39 value? Just multiply by 13. So just multiply 13 throughout the equation. What the value will be? Here 13 3s are 39. Just multiply here alone. So 3 into 13 is nothing but 39 into 15 minus 13 into 2 is 26 into 21. Now we just compare the original question with this expression, linear combination. See, 15, 15, and inside of near to the 15 is x. So you can take this value as a x naught value. So this is a one of the trial solution. Okay, and see y. So 21. So 21 is inside, and before the value of 21 is y. So you can take this value minus 26 as the y naught value and equals 39. So just compare the given question with the linear combination. Just compare and say what is x naught. This is a trial solution. Trial solution is nothing but the so many x naught and y naught possibilities are there, but the general assumption is x naught is 39, y naught as minus 26. So this is the trial solution of this problem. Just substitute in the general equation. What is the general equation of x is x naught minus x naught plus b by d into t. Just substitute is, what is the x naught value is 39 plus b. What is your b? The corresponding y coefficient 21 by, what is your d? The least coefficient is 3 into t. This is x equal to 39 plus 21 by 3. 7 3s are 21. So 70. This is the x value. And similarly, what is y formula is y naught minus a by d into t. See, y naught, what is the y naught value is minus 26 plus a. So here minus a is nothing but the corresponding x coefficient 15 by 3 into t. So your corresponding y value is minus 26. 15 by 3 is 5 minus 5t. So this is the final answer. T belongs to Z. How to check whether this value answer is right or not? Just substitute any value of t. Just substitute t value as 0. What happens? If you substitute t value as 0, What happens to x as 39? Y value is minus 26. If you substitute this x value and y value in the general equation, you will get the value as 39 as the right hand side. So this is a way you have to check for the solution whether it's right or not. So this is a way you have to follow to check linear Diophantine equation. If the linear Diophantine equation is solvable, then the solution exists. This is the solution of this equation. Thank you.